Hello everyone. In this video we are going to discuss about ARM simulator. As you can see here, this is the ARM version 7 simulator environment. You can select the language as C language or ArmV7. In this video we are going to discuss about ARM version 7. So we are choosing ARM version 7. So if we see the environment, we have the at the left side of the simulator we have the status of the registers as R0 register, R1 register, R2 registers, and so on. And we also have call stack, trace, watch points, symbols, etc. And has in the settings we can see the number display options also, as the size is words or byte, half word or word, and the format is hexadecimal or decimal unsigned or decimal signed. And in the memory, words per row 4, 8 or 16, you can choose this. And at the bottom of the compiler we can see the messages, whatever the program we are going to write in the editor. If there are any errors or if there are any uh, message that the compiler want to give to us, will be visible at the bottom. And here we can see the deassembly also and the memory also here. And in the editor we are going to write our program, and then we need to compile and load our program. Then we can see if there are any errors in the message box. If there are no errors, then we can see our program here in the assembly tab. And at the top you can see there are various tabs here, like file. You can open the file or save the file or share your file. And for help you can check the documentation if you want how to use this compiler or any other information. And as you can see here, there are various execution one instruction. It means it will be executing one instruction at a time. That means line by line we can execute our program. Or step over, it means it will execute all the instructions at a time. And continue, and we have stop button also, and we have restart button, and we have reload button also. So if you see here in the editor section, our compiler gives us two lines defaultly. These two lines will be written in every program commonly. What does these two lines define means? The global start and start are the directives. It means the global is a directive that tells the assembler to make the symbol that follows it visible to the linker. It means here underscore start, this is the symbol. What does this global tell is, whatever the symbol, in this case that is start, it is visible to the linker. This underscore start is the symbol being made global. It means the start is a symbol that is available globally. That means throughout the program the start is available. So we can see in the next line we have underscore start and a colon. This is a label that marks the beginning of a code section. This means if we write this line, the compiler get to know that after the line, whatever the lines we are writing, it will be considered as our code. The colon, as we can see here, there is a colon, and in the first line there is no colon. This colon will differentiate between a symbol and a label. This underscore start is a symbol which will be made global, but this is a label. So whatever we are writing after the underscore start colon, it will be treated as our main program. So now I will be demonstrating about a simple addition of two numbers program. So here is a simple program for addition of two numbers. Here I have written move R0 comma hashtag 2. It means I am moving the value 2 into the register R0. This hash symbol indicates that we are moving the immediate value. It means directly 2 will be loaded into R0 register. And I am moving 3 into register R1. And I am simply adding those two registers and saving the result in the R0 register itself. Now we need to compile and load our program. Yeah. In the message box we can see that compile succeeded. It means there are no errors in our program and it has automatically jumped into disassembly section. Here we can see, here is our code. Here is our code at start and end. Now we can execute it step by step. Let's see by executing step by step. Yeah. After execution of first line, we can see here in the register R0, 2 is loaded into R0, and next 3 is loaded into R1 register. If I go one step forward, I will be getting the result into the R0 register. Yeah, as we can see, R0 register we got result as 5, which means addition of R0 and R1 I am storing in the register R0, which is 2 plus 3 is 5. Thank you.